Our next presenter is John Watts from the Texas Discovery Center, and his presentation is titled, There's Gold, or Chrysos, in Them Thar Hills. John Watts was born and raised in North Florida, where he developed an early interest in insects. He spent most of his free time exploring the acres of woods and swamps behind his house. John received a master's degree in entomology from the University of Florida, where he specialized in insect husbandry. It was in college that he began a lifelong interest in the biology and systematics of leaf beetles. John's professional career started at the Cockrell Butterfly Center at the Houston Museum of Nature and Science, and he has been in the live butterfly exhibit business ever since. He spent 7 years at the Butterfly Pavilion and Insect Center in Westminster, Colorado, before settling in Dallas. With over 30 years' experience in the live insect and butterfly exhibition trade and an inordinate fondness for nature in general, he gladly shares his wealth of knowledge at Texas Discovery Gardens. Favorite animal he most wants to see? Leaf beetles, of course. Let's give it up for John Watts.
Okay, can y'all hear me? Oh, yes, definitely. Because there's such a big group, I'm going to have to talk fast, and I'm going to have to leave out the subfamily and family slides just to keep it in the 20 minutes here. But let's start with the very first one. And all you need to know on here is that look at the tarsal formula. With Chrysomelidae, it appears to be 444, even though it's actually 555. And the second antennal segment is equal to or slightly smaller than the first segment. That separates them from their relatives, the cerambycids. Let's pass the Chrysomelidae and start with the really big and bold potato beetles. Most species in this group feed on solanaceous plants, and these happen to be some of the largest of the Chrysomelidae, and as you can see, they're very beautiful creatures. There are 6 species in Arizona, of which 4 out of the 6 feed on solanaceous plants such as Solanum, Lycium, and Physalis. They're very easy to breed on host plants, even potted plants, but it's difficult to get them through the winter diapause. 2 other species, the Tumamoka is another one that feeds on Solanum, Physalis. And the other species, Peninsularis, feeds on puncture vine and Arizona poppy. There's one more species that you're probably familiar with, and this is the one that feeds on the burrow bush, Hymenoclea monogyra. During the monsoon seasons, as you can see, they're very boldly patterned. I like Chrysomelidae because you can teach many different ecological concepts with the group. And with the potato beetles, they're a good example of aposematism. They also practice thanatosis, that is, they play dead. So with aposematic insects, they usually sequester the compounds from their host, and because they're unpalatable, they advertise that usually with the color patterns. They are very conspicuous, and then the thanatosis just allows them to not allow the predators to chew them too quickly so that they can get some of the blood, the hemolymph, which does bleed through the joints of their legs. If you've ever picked up any of these guys, you get that yellow-orange fluid on your fingers. That is their hemolymph. If you've ever want to know what it tastes like, put a little bit up on the tip of your tongue. It is not nice. Related to them are the calligraphy beetles in the genus Calligrapha. And this particular 2 species here, Serpentina and Dislocata, they both feed on the same host plant, which are globe mallows in the genus Sidalcia. This brings up an interesting thing, in that how do they actually both feed on the same plant without competing with each other? I don't know yet for sure, but there must be some sort of resource partitioning going on with them. Like I said, they both feed on the same host plants. Perhaps one feeds only on the new growth and the other only on the old. There's also another thing that they're, interestingly enough, is that Serpentina, the larvae are gregarious, and they're black and hairy, and see these big clumps of larvae. Whereas the other species, which is much more cryptic in coloration, the larvae are not gregarious at all, and they're pale in color. Related to them are the zygogrammas. I don't know what the common name for this one is. I couldn't find one for them. But most species in this genus specialize on composites, and they tend to be very host-specific as to which species they go on. For instance, Zygogramma continua is found on Heliomeris multiflora, whereas Heterotheca is found on Heterotheca, the camphor weeds. Disrupta, malvae, and tortuosa feed on ragweeds or ambrosia, which there are plenty of them here. Exclamationis feeds on sunflowers. And these species here, there aren't any records in the literature as to what species of composite they're on, although I've collected them on composites that are never in bloom, so I'm not quite sure what the plants are yet. And these would bring up another interesting lesson, and that is speciation and mimicry. There is rapid speciation in this group of beetles. And as obviously they look very similar to each other, and you would expect that when they're closely related. But because many composites have lots of compounds in their foliage and stems that are not edible, it probably is resulting in a form of Mullerian mimicry, and that is where all individuals of all species are inedible to predators. Which, by the way, reduces the amount of any individuals to be fed upon in order for predators to learn a lesson. There's only one species of Chrysomelidae here, that's Sonoran, and they feed on willows. You're probably familiar with Chrysomelidae from the rest of the U.S. In fact, most of these genera will be found throughout the U.S. They all mostly feed on willows, and as a result of the compounds in willows, they're very toxic, and you can smell that in them whenever you touch them. The larvae will excrete the compounds, the adults will as well. Like I said, we're going to go past these, but the PDF that goes with this will have that information there, and that will help you separate the different subfamilies. I'm only going to do one genus in this group because it's a horrible group to play with. They're very difficult to identify. Colaspis is the most common genus here, and they're very prolificous on various types of plants. Interesting enough, the larvae are root feeders, so there's not much in the way of competition between the adults and the larvae. Cassidines. There are two types. There are the tortoise beetles proper, which, as you can see, do kind of look like turtles in a way. And the vast majority of species in this area feed on morning glories and their relatives. Note the larva over there on the top right. I'm going to talk about that with predator avoidance. The shape of the body of cassidines allows them to adhere to leaves where there is no way for ants and things to get to them. Also, their tarsi have little sponge pads on the bottom that act like suction cups, and they adhere to that, and the ants can't get in to bother them. The larvae, as you saw, are covered in what we call a furcal frass. It is indeed their frass. And it not only will protect them from predators and parasites from above, but it also includes compounds from the plant that have been concentrated. So even the fecal matter is poisonous to potential predators if they try to get it. And you saw those side armatures on them. Those also help to keep the ants from bothering them because they can't get through those. A few more tortoise beetles, and these also all feed on morning glories. And the next lesson is that crypsis and rapid color change. Unlike most insects, tortoise beetles can change color almost instantly, within a second or two. Some of them look like dewdrops, and then they can change to red, which would probably make them look more like ladybugs, and there may be a form of mimicry there going on. There's one other species, and one of the larger ones here, and that's the Arizona tortoise beetle, and it feeds on the canyon ragweed. And you can see they have two different color morphs. Leaf-minding leaf beetles are another tribe of the hispines, which cassidines belong to as well. And these are more elongated. And I got two genera here, Stenopodius, which are found on globe mallows, and Micropala, which are usually found on composites such as brittlebush. And with these, I'd like to give the lesson of coping mechanisms against harsh environmental conditions. They have very thick exoskeletons, which help reduce the potential for desiccation. And the larvae are found in between the leaves. So the common name for this group are leaf mining leaf beetles because the larvae produce leaf mines, and that will protect them from harsh conditions as well. Cryosaurinds. The genus Lima is found on solanaceous plants, and especially Datura, Physalis, and Solanum. The larvae often cover themselves with liquid feces. You can see in the center slide there a bunch of larvae with liquid poop on them. Ulema and Neolema are two other genera that are found here that are mostly breed on plants in the Commensalism, which include spiderworts and dayflowers. These make great examples for talking about stridulation and mimicry. They have a special process on their thorax that they can make squeaky noises with. And because of the color pattern, they actually mimic mutilids and ants, or formicines. And so both an auditory as well as a visual form of mimicry is going on here. They may produce, as a result, because of them looking like ants and mutilids, that's a Batesian form of mimicry, which is where you have one that's a model that's poisonous, and the mimic is not poisonous, but mimics the poisonous one. Galericine, leaf skeletizing, and flea beetles. Again, there are two groups in here. Let's start with the flea beetles. Altica. Many of them breed on plants in the primrose family, evening primrose family. And they're difficult to identify the species because, as you can see, they all kind of look similar in coloration. Note the beetle in the center. That is not an Altica. That's an example of aggressive mimicry. That is a ground beetle in the genus Lebia, and Lebia prey specifically on Chrysomelidae, either larvae or adults. And what they do is they actually look like the species of leaf beetle that they eat. So it's like a sheep in wolf's clothing. I mean, a wolf in sheep's clothing, excuse me, got it backwards. Dysonitia. These are large, bold-colored flea beetles. They tend to be very specific as well as to what species of plant they were found on. Now, with the bold patterns between that and Acushulina, which are very closely related, the way to tell the two apart is look at their tarsal segments. The last one on Acushulina's metatarsus is swollen, whereas in Dysonitia they are not. And most of the Acushulina feed on mints and scroffs. I like to use these to talk about saltatorial escaping behavior. Saltatorial, of course, means to jump. And flea beetles have that enlarged metafemora that have mechanisms that allow them to propel themselves quickly into the air. And so the bold patterns on them may not necessarily be an example of aposematism, because if they were aposematic, there would be no reason for them to have to hop and get away from potential predators as a result. So it may just be saying, look at me, you can't catch me, no, 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 no. Cucumber beetles. This is in the same subfamily. And there are a number of genera of Galericines found in the area. Many of them feed on flowers and of cucurbits and various other plants, hence the name cucumber beetles. The larvae are subterranean root feeders. And I like to use these to talk about resource partitioning again. And this is one of those examples of why complete metamorphosis is probably so successful for insects, because you can actually have the immature stage feed on something completely different from the adults, and therefore there's no competition between them over food sources. Ophrya. There's only one species in this genus, and it's in North America, rugosa, and they found it on Belleroperon, Justicia californica. The bold colors would indicate that it's probably aposematic. Pteropda, there are a number of species in this genus here, and they're fairly large for Chrysomelidae. They're host-specific as well, mostly on composites. But the larvae are external leaf feeders, And they tend to be very brightly colored, oftentimes metallic green and blue and purple. I'm not quite sure what's going on there. It could perhaps be a form of aposematism. Cryptocephalinidae, the cylindrical leaf beetles. Let's start with the tribe Clytoene. And the short-horned leaf beetles like Megalostomus are fairly common in this area. The adults are found on Mimosaceae. That would be things like acacia and mimosa and mesquite. You find them on the flowers often. The larvae are case bearers. In fact, with all the cryptocephalines, the larvae are case bearers. And they're associated with ants. So that brings up symbiosis. And in fact, this is a form of commensalism. The larvae are found in the ant nest where they consume the detritus. In fact, there's one species that deliberately cuts off a piece of leaf and drops it to the ground near a nest, probably with an egg attached to it. A few other genera of shorthorn leaf beetles, quite common here, is Coleorosina, Coleothorpa, and Casanoptera. Again, they're case bearers. You can see on the bottom right some case-bearing larvae of one of the Coleothorpas. The larva of this one was found under rocks, so nobody really knows what the larvae do and feed on. Two other genera, Saxonus and Eurodera, are very boldly patterned, as you can see. And it's unknown what their immature stages do, or what they even look like. Cryptocephalus, the type genus for the subfamily. There are 22 species found in Arizona. The larvae, again, are case bearers and are found in leaf litter. The adults are found on foliage and flowers. And the one on the left and the one on the right, those are examples of, I probably will come a little bit later, but they're detritivores as larvae. They don't usually feed on the living host. They feed on the leaves that have dropped to the ground. Pachybrasis is the other one, and again, just like Cryptocephalus, they're usually found on the same host, both as larva and adult, but one on the dead leaves as a larva and live leaves as the adults. The egg case of them is produced by a special structure in the abdomen that produces plates of fecal material. And what the female, you can actually tell the males and females just by looking at the last segment of the abdomen. And the females is concave. She will hold the egg with her hind legs in that concavity, press a little crap plate, put it on there, turn it, put another crap plate on there, turn it, until it's completely covered. By the time they're done, they look like hand grenades and pine cones. And they drop them to the ground, and the larva uses that as their first case, and they add their own frass to it as they're growing. And here's Pachybrachus, the other one. This is the largest genus in North America, 150 species. And there are about 55 species I could find on the internet in book and in literature that occur here in Arizona. These actually, a lot of them are flower mimics. They will feed on the flowers as adults, and they look like just the same color as the flowers. The previous picture, I'll just run back real quick. The one on the left is found on the catkins of willows, and the one on the far right is found on creosote bush, which has yellow flowers. Gryburius is larger relatives to Pachybrachus. The best way to separate them from them is look at the prosternum. It's concave on Gryburius and flat on Pachybrachus. There are the only species I'm familiar with here is Montezuma, and you find them on foliage of mesquite flowers as well as oak. The larvae are found in pack rat nests, so this is another example of commensalism again. And of course, commensalism is that form of symbiosis where you have two organisms that live together. One of them is taking advantage of the other one, but it's not causing any harm to the other one. One of my favorites, the warty leaf beetles, Chlamysis, eczema, and Neoclamysis. Oh, okay, it looks like I'm at the end here, but let me run this real quick. They're frass mimics. They look like caterpillar frass. Last one, seed and bean weevils, which I can talk more about later if y'all want to. All right, well, sorry, I knew it was going to be fast. And you should see how many genera I had to drop out.